Hey guys, and welcome back to another video. In this video, we'll be discussing 1.6 polynomial functions and real zeros, part 2. So in the previous video, we discussed how to find the rational zeros of a polynomial function. Now, in this video, we will discuss how to find the irrational zeros of a polynomial function. Okay, so let's get started. So to begin with, let's discuss the intermediate value theorem, as that will provide useful in finding irrational zeros. So intermediate value theorem. So essentially what it says is let a and b be real numbers such that a is less than b, and let f be a polynomial function then if f of a is less than f of b, there is at least 1 0 between x equals a and x equals b. Right, so essentially what this is saying is if you have like some polynomial function and like it looks like something like that, right? And let's say like x equals a is right here, so then f of a would be that point, and then let's let b be right here, and so then f of b would be like that point. And then clearly from the graph we can see that f of a is negative and f of b is positive, so they have different signs. And so what the intermediate value theorem is saying is that if f of a and f of b have different signs, then there's at least 1 0 between them, right? So it has to cross the x-axis in order to change signs. Okay, good. But so with this notion in mind, it will help us explain the method used to find irrational zeros. It's a numerical method. It's called the bisection method. So basically what the bisection method is like, so the first step is you have to find some interval. So find an interval in which the zero lies. Zero of polynomial. So basically the first step is you have to like choose some interval in which you're sure that the interval lies, or like the zero lies in. And this is what the intermediate value theorem is helpful in doing. It helps us get that interval. So that's how you can use the intermediate value theorem. And then the second step is like the formula, which is basically c is equal to a plus b over 2, right? So what this is saying is basically once you have that interval, you're going to split it in half, and then you find f of c. So if f of c, so let's say like f of a is negative and f of b is positive. Okay, so f of a is negative and f of b is positive. All right, so if f of c is positive as well, then that means that the zero lies between a and c. So we basically shortened the interval from a to c. But if f of c is negative, then that means that the zero lies in between c and b. And we just keep doing this until we have like a zero that's like we're satisfied with, right? Which is within a reasonable error. So that's essentially what you have to do. Okay, so with this in mind, let's do our first example. So let's find the zeros of f of x equals x to the fifth minus x to the fourth minus 1. Okay, so if you see this problem, the first thing you'd want to do is do like the rational root test to see if it has any rational zeros. But if you do the rational root test on this, you will get that none of the rational zeros works. So the next step is to test irrational zeros. So we'll do the bisection method. So the first thing we can do is we can like test points and like see if it's like and if you like form our interval. So if we test like 1, we get 1 to the 5th minus 1 to the 4th minus 1. And this gives us 1 minus 1 minus 1. So that gives us a negative number. And if you did f of 2, you'd get 2 to the 5th minus 2 to the 4th minus 1. And this gives you overall a positive number. So now we find an interval, right? Because if a is equal to 1 and b is equal to 2, f of 1 is less than or has opposite sign of f of 2, meaning that the 0 has to lie in between 1 and 2, right? So that's our interval from 1 to 2. And then we can apply this little formula. So c is equal to a plus b, so 1 plus 2 over 2. And that gives us like 1.5, right? So, and then what you do is you just find f of c. So in this case, f of 1.5. And I will tell you that you get a positive number. If you want to see the actual value, you can do it yourself, but I'll just tell you that you get a positive number. And so that means that b is positive and c is positive. So that means that the new interval is from 1 to 1.5. Right? Because we know that if we put 1 into our function, we get a negative value. And we just found that if you put 1.5 into our function, you get a positive value. So we've basically shrunk this interval in half, and we're getting closer and closer to the 0. Okay, so I'll call this like iteration 1. We'll do like 3 iterations for our purposes. Or so iteration 2. So then you just keep doing it, right? So now a is 1 and b is 1.5. So c is 1 plus 1.5 over 2. You get 1.25. And again, I will tell you that c is a negative number. Okay, so now we found that c is negative and a is still negative, but 1.5 is positive, right? So in between 1.25 and 1.5, the 0 must lie. So our new interval is 1.25 till 1.5. Okay, that's our new interval. Alright, good. And then we'll do one more iteration. So we have c is equal to like 1.25 plus 1.5 over 2, and you get like 1.375. And then f of c, I'll get the actual value now because this is probably going to be our estimated 0. It is negative 0.0726. Okay, good. So like you see, f of c is negative. 1.5 is a positive value though, so that means that our 0 lies in the interval from 1.375 until 1.5. So for this, in this video, we'll just stop here, but you could keep doing this like pretty much forever, and you could like almost get the exact 0 if you kept doing it. But for our purposes, this is good enough. So our 0 is approximately negative 0.0726, and it lies between this interval. Alright, so I'll say like x is in this interval. Okay, good. Let's do another example. Let's do like one more of these. Alright, anyway. So let's do another example. Okay, so let's say we have f of x equals x to the 4th minus 3x cubed plus 4. Okay, so same thing, right? So first we have to find an interval in which the 0 lies, and we can do that using intermediate value theorem. So let's just test points. So let's just test f of 1 again. And you get 1 to the 4th minus 3 times 1 cubed plus 4. And this gives us the 1 minus 3 plus 4. That will give us a positive number. Okay, and then if we test f of 2, we will get 2 to the 4th minus 3 times 2 cubed plus 4. And that gives us, so we have 16 minus 24. That's negative, and then plus 4 still negative. Okay, so this interval works. So we'll start off with this interval from 1 to 2. First iteration, a, which is 1, plus b, which is 2 over 2, so you get 1.5, and you find f of 1.5, and I'll tell you that, okay, so f of 1.5, you get 1.5 to the 4th minus 3. You get a negative number. So that means our new interval is from 1 to 1.5. Okay, good. Next, do one more. Let's do 2 more iterations. Now you have 1 plus 1.5 all over 2, and that gives us like 1.25. And if we find f of 1.25, you get a 0.582. So that's a positive number. So now our interval is from 1.25 till 1.5. And let's do one more iteration. So if we do third iteration, you get c is equal to 1.25 plus 1.5 over 2, and that gives us like 1.375, I believe. And if you find f of 1.375, and this is equal to, see, you get negative 0.224 approximately, and so that our interval becomes from 1.25 until 1.375. And like I said, for our purposes, 3 iterations is good enough. But yeah, our 0 is approximately negative 0.224, and it lies in this interval, right? So x is in this interval. Okay, good. So yeah, that's pretty much it for this section. That's like the main method that you can use to find irrational zeros. I hope you guys enjoyed this video. If you did, make sure to leave a like and don't forget to subscribe.